Hello, administrators and educators. This is video series part 3. Very excited about this one because these are some things that you can implement in the school, in a classroom immediately and have great effects. And those two things are models and language. Okay, so models, there's two really important models, the number line and the bar model. They're both the visual models. So if you were listening to the DMT Framework, we talked about how important Jerome Bruner talked about inactive physical models, iconic visual models, and symbolic models. So these are the two most important iconic models. Why are they important? Number one, you have a visual look at the mathematics. They are also the way to get at the concept. Conceptually, how does the mathematics work? Why does it work this way? That is critical. So you only get that from these visual models. The wonderful thing about the number line bar models, again, you can use them from kindergarten all the way up through high school. So they never disappear. They may be modified in a certain way. So there are the 6 structural words that are really critical that we talked about earlier before, and that is the unit, iterate, partition, decompose, compose, and equality, or the equal sign. So those 6 words, well, I'm going to use as many as those as possible to go through 4 examples today. And so just to show you the language and models, we're going to focus on a first grade, a 4th grade, a 6th grade, and 8th grade, just so you can see how those models and language work. So you can see that it doesn't matter the grade level, they work in all situations. Okay, here's example number 1. So we're thinking first grade, and we're going to talk about place value. So place value, a lot of times you're thinking ones, tens, hundreds, absolutely. But to really get kids to understand place value, we're going to use the number line. So let's examine the number 23 and 32 and what is the difference. So I'm going to show the number line first and then connect it to the bar model. So always ask kids, what number do we start with? Most often they're going to say 1. Nope, we're going to start with 0. 0 is a really important number. Okay, and if we're focused on 23, we're going to focus on the tens. So the digit 2, so that's important. Talking about place value. So there's a digit 2 and a digit 3. The 2 is in the tens place. So it's worth 2 tens. So we're going to construct 10. And at this point, I like to stop with the kids. Here, what does each of these digits mean right now? We have 0 units of 1, then we have 1 unit of 10. Okay, so now, if I make another jump of 10, now we're at 20. So here again, we're going to ask the students, so this digit 0, what does it mean? I have 0 ones. What's this digit 2 mean? That digit, so that worth idea, it's worth 2 tens. Where are they? They're 2 tens. So that's perfect. Okay, if we're working on 23, we now have the 2 tens. Now we're going to focus on the 3 ones. So I'm trying to do that proportionally. 1, 2, 3. There's 23. Again, we go back to the digits. Here's the number 23. What does each of these digits? You can even go from left to right or right to left. As we talked about with the framework, we talked about misconceptions and mistakes. I like to play around a little bit. So this 2 is worth the 2 tens. There they are. This 3 is worth 3 ones. Here's what they are, 3 ones. Okay, so the number line really helps you talk about what place value is. So a lot of times we'll talk about it as tens and ones, and we'll say we have 3 ones and 2 tens. This is in a table format. It's abstract. It's the symbolic. It doesn't really help them grasp the concept of what's happening with these units. So here we can go back and talk about what are the words, structural words. Decompose. We decompose 23 into its place value units, 2 tens and 3 ones for 23. Now the bar model also comes in. That was the second model that we talked about. And we can take, so this time I'm going to do 32. So focus on the 3 or the 2, does not matter. So just be a little bit different this time. I'm going to start with the ones. So here, I've got 2 ones. So there's my 2 ones. I could label it here. I like to show with an arc that there's 2. Because each of these represent units of 1. So I don't want to label it 1 and 2 because I want to focus on that's a unit of 1 and that's a unit of 1. It really helps understanding quantity as well. Now we're going to focus on those 3 tens. So now I can create a 10, a unit of 10. Where am I? So I'm at 10, but I still have the 2 ones. Now, when I write 12, I can go back to the same questions. Where's my 2 ones? They're right there. Where's my 1 unit of 10? Right there. Okay. Now I have second 10. Where am I? I'm at 22. So there's my 2 units of 1 and 2 units of 10. Okay, I'm not done. I need another one. So I do another 10. I'm at 32. Asking the same questions. Here I'll start with the 3. What does that 3 mean? It means 30 or 3 tens. 10, 20, 30. There's my 3 tens. 2, I still have my 2 ones. So just these 2 models and using that language help us really understand place and value in a visual representation before we move into just the abstract numbers or into a table like that. Okay, now we're going to move to 4th grade, equivalent fractions. So third fractions typically starts in 3rd grade. I'm going to show you a 4th grade example. So if you have 2/3 times 2 halves, so equivalent fractions, we multiply. So the procedure tells us to multiply the numerators. 2 times 2 is 4, and 3 times 2 is 6. Great, that's the algorithm. Okay, but we're going to talk about conceptually, why does it work? And can you explain what each digit means? What is the operation? What's happening? That's harder to explain if you've never learned it this way. So we're going to use a visual model. I'll use the bar model this time. So here, I'm going to have the unit of 1. So that's what a fraction, we're talking about a unit of 1. And we're going to start with this denominator of 3. We're going to partition that unit of 1, that's what that's saying, into 3 equal units, 3 small units. There we go. So I'll label them 0/3, 1/3, 2/3, and 3/3. Okay, so that's what that digit 3 is saying in the fraction. This 2, the numerator, is the count. It's telling you I have 2 of those 1/3. There's a 3rd and there's a 3rd. So I'll shake that in. So I iterate that 2 times. Okay, now we're going to move this. So now we're going to multiply. So we're operating on this fraction. And so this, we're going to focus on a half. But this half, because we're multiplying, is in relation to this 3rd unit. So I have to take every half unit, or each 3rd unit, and partition it into 2 smaller units. So that's referring to this as its own unit. So take half of that, half of that, half of that. Well, once I do that, and we go back to 1, to name that fraction now is 1, 2, 3, 4, 5, 6. That's where that 6 comes in. So now I have a new unit, which are 6. So I'll label all those here. Okay. This 2 now, as our last one, is a count, but it's saying count 2 of the new units for both 1/3. So there's 1, 2, 1 6 units in this 3rd, and 1, 2, 1 6 units in this 3rd, 4 on the other. And that gives us the 4 and 1 6 units. So again, here, the ability to use a visual representation and those structural words give us a deeper understanding of what actually happens. And tune in for another video where we talk about when these change to like 1/2 and 3/2. Okay, now we're going to move to our 3rd example, and we're going to do percents. So we're in maybe 6th grade here. The example will do 65% of 200. Could be any. Okay, so again, the language, and we're going to use the bar model here to really get a better sense of what's happening with 65% of 200. So instead of memorizing all the different rules for multiplying that. Okay, so here I have a bar model, and I'm going to represent that from 0 to 200. So that's 200. That entire amount is my 100%. Okay, all 200, I have 100%. Okay, I need to understand where 65% is. So a lot of times we use a 1, 2, 5, 10 type of rule here. So here on the 5 idea is really 50%. So 50%, just to get a sense there, I'm going to take half. So half of 200 on that 100. So I know that 65 is going to be somewhere over here. But if we have 50%, I'm going to go down to 10%. Why 10%? Because it's a lot easier to focus on 10% of 200, which is 20. Just that place value right yet. But then half of 10% is right down here, 5%. Half of 20 is 10. So that's going to allow me now to take 50%, which is 100, take 10%, which I'm at 60%, and that's 20 here, so it's 120, and then I have 5 more percent, so that there is 65%, and that 5% is 10, added on to the 120, which is 130. So 65% of 200 is 130. So that gives you a really good sense of what's happening with the percent and these differences. Now, I can change any of these amounts where I know that there's 100%. If it was 120%, I know I've increased the amount. So whatever that is, I can go back and find 20% and add on. So it doesn't matter which of these numbers are missing. The barbell itself just helps you really get a better sense of what's happening with the mathematics. So while I was in a class working with percent, as soon as we added the visual model to it, we had students who were missing different components. Maybe 20% of kids were getting them all correct. We do the visual, the barbell for it, instantly went into 85% of them were getting every problem correct, just like that. Okay, now we're going to move to our fourth example. We're somewhere around 8th grade. We're going to focus on exponents. This is actually one of my favorite ones. Getting the students to really understand what's happening with exponents and seeing it visually. And then that actually helps them understand those abstract numbers. What is that base of the exponent? So let's take a quick look here. So we're going to focus on the number 3. Okay. So you have the number 3. We're going to say that is 3 to the first. Okay. So when you have 3 to the first, and we'll do a number line this time. For my other examples, I was doing some bar bundles. So here, I'm going to focus on 0, and I'm going to say that is the unit 3 right there. And I'm creating an R model with my number line. So that's what that's saying is I have a unit of 3. Okay. So that is on top here, 3 to the first. So now we're going to move to 3 to the second. A lot of times we call it square because there is another visual where it looks like a square. However, I'm going to keep this linear using the number line to get an understanding there. So 3 squared is 3 iterations. That's one of those structure words, 3 iterations of the unit 3. So here's the unit 3. I'm going to do 3 iterations. 1, 2, 3. Where am I? 3, 6, 9. I'm at 9. So 3 to the second power is 9. Okay. Now we're going to focus on 3 to the third. So 3 to the third, we still use the same sentence frame, where now we're saying we have 3 iterations of this previous unit, which is 3 squared. So you can think of this as 3 to the third is also 3 to the second times 3 to the first. So we have that 1, 2, 3. So we're at 9, 18, 27. So 3 to the third is 27. So a lot of times we talk about 3 times 3 times 3. That's fine. 3 times 9. Yes. 3 times 3 squared. So there you see that exponent there. Now, if we were to continue, it would be 3 to the fourth. And we say same thing. We have 3 iterations of 3 to the third. So we have 1, 27, 54, 81. So it starts getting very large very quickly. Okay, if we reverse that process, so we're at 3 to the third. Now I want to go to 3 to the second. I'm doing 3 partitions, 3 equal partitions. So here's my 3 to the third. So we have the 1, 2, 3, and I'm back to 3 squared. Okay, I'm at 3 squared. I do 3 partitions of 3 squared. I'm back to, there's my 1, 2, 3. I'm back to 3 to the first. And while I'm doing this, because now I'm going to continue, I'm at 3 to the first. So Ted tells me I'm going to do 3 partitions. Okay, so I partition the 3 into 3 equal units. Where am I? Right here? I'm at 1. So that is considered 3 to the 0 power. 3 to the 0 power is 1, which, okay, if I move to any base, so I'm at 5, I'm at 9, it does not matter. If I'm at 5, it'd be 5 partitions, then I'm back to 1. That's why anything to the 0 power is always 1. Let's continue. 3 to the 0. I partition the unit of 1 into 3 equal units, and I'm at 1/3. So that's 3 to the -1. So right now we have that visual of I'm partitioning less than 1. And so negative exponent doesn't mean I'm negative numbers. It just means I'm less than 1, and I've done 3 iterations. I could continue that. So if I focus on 3 to the -2, then I'm taking that 1/3 unit, partitioning it 3 times, which makes me have 9 of those. I'm back to 1/9. So then the question becomes, if I have 3 to the a huge negative number here for an exponent, does it ever mean we're going to be at 0 or in negative numbers? No, it just keeps approaching 0 and gets smaller and smaller and smaller. So again, the visual model, number line bar model, gives a real nice insight into what these digits means. And once you have that in your head, then your ability to now do the different algorithms with exponents, it's going to be right there for you. Another question, so we talked about in the DMT framework, misconceptions always kind of pop up. So one of the misconceptions is right here. A lot of times kids will think about it as 3 times 2. So 3 times 2 is 6, that's part of it. They also will say, well, if I'm at 3 the first and at 3 the second, if we're focusing on that, that it's just this, it's 2 more. So that's an additive way of thinking about it. It's like, yeah, we have 1 3, and then there's going to be 2 more. That's not related to that. We have to think multiplicatively. So we're thinking that we have 1, which is times 3. So we have to include that 1, 2, 3 each time. So again, that's another conversation we'll have later for some different examples, but this additive versus multiplicative idea of thinking about why kids have some of these misconceptions. Okay, that ends video series number 3. We have video series number 4 coming up next week, so stay tuned for that. Hopefully these examples got you excited. I've been teaching them for 30 years, and I still get excited teaching them and watching kids light up, and teachers light up too, going, oh my gosh, I truly understand math. So we would love to have our conversation with you. Go ahead and click below, and we will talk with you about how you can actually implement this in your school and make changes.